Hello guys, welcome back to my channel. And today in this video we will talk about the different type of distribution that we use in a statistics. So it is presented by the Scientist Diary, which is my channel name. So before moving into the agenda, I want you to subscribe my channel, to hit the bell icon, and to wait for my new videos which I will be upload soon. So that new videos, I want to announce that these will be very helpful for you, because there I will explain the complete Python for data science, some libraries, and also some end-to-end projects that will leads you to your final year project, especially in data science or you want to do in AI. So I will post different projects from different domain. So the request is to you to subscribe my channel, hit the bell icon, and wait for the new videos. So let's try to learn what are the distribution in statistics. Let's go. Well, here, what is a distribution? A distribution, it's a mathematical function which is used to represent the occurrence of the elements, and also the probability of these elements. Which means that, for example, I have a column called age, on which contain different types of values. Like, for example, there are the people who are the age who are of age 24, who are of age 28. But distribution will tell me all these things in a graph, in that sense that 24, which age section have more values, which are less, and it will actually shows everything in the help of a graph, and that will actually call the distribution. So you can call it distribution is just like a container which contain a multiple values, and it is used to represent that values in the help with the help of a graph. So it is where to visualize and understand how the data is spread out. I explained you already. It's like a map that shows most of the data points are located. So this is actually the example of a distribution. So here we have two types of distribution when we categorize them. The first is a discrete distribution. The second is a continuous distribution. In discrete distribution, there is a limit of certain numbers. For example, we have categories, and also the numbers in a some sort of range. But in continuous variables, there is no range of a number. These are actually called the continuous variable. They will be in points. They will be, you can say, at higher range. In discrete we have low some, you can say, we have some range. For example, the number will be found between 1 to 100, 1 to 50, 1 to 40. There will be some sort of range. Okay, so in discrete distribution, the first distribution is actually called the Bernoulli distribution. It is used for the binary outcomes. It is, which means success or a failure. So what will we do? When we flip the coin 10 coins, then with the help of a graph, it will represent that how many times 0 occur and how many times 1 occur. Whenever we have a two outcomes and we plot them, then it becomes a Bernoulli distribution. That's it. Nothing else. The second is actually the binomial distribution. Binomial distribution, it represents the number of successes in a fixed number of Bernoulli independent Bernoulli trials. For example, I have a coin which contain head and tail. Okay. So I will flip it 10 times, and I want to find how many time head occurs. So when I find that time, it becomes a binomial distribution for that head, which means that I represent in the head, I represent the number of successes in a fixed in the fixed interval of in the fixed interval trials. For example, as I told you, head. Uh, so it will show me that how many times head occur. Just simple. The next one is actually a Poisson distribution. It is also one of the important distribution when it comes to the data science or statistics. It represents the modal number of events in a fixed interval of time or space. Okay, it actually represents that the number of events we have occur in some sort of time, which means that I have an time, for example, 1 hour or 2 hour, and I want to check how many time a particular event or a number of event happens. So it's moved toward the Poisson distribution. As example, for example, we have a store and we want to find how many people came at 1 hour. So whenever we find the number of people arriving at 1 hour, on the right side you can see the graph, and it will show you, for example, at 4 to 6, how many people come here. You can count it here. So this actually, it shows the Poisson distribution when we model the number of events based on the some sort of interval. Okay, let's move forward. Another is the Gaussian geometric distribution. Okay, in geometric distribution, we actually find the number of samples that is needed to have a success, to reach the first success. For example, I want to I have a coin which will I flip for many times for different sample times, and I want to get head. For example, I flip it 5 times and I could not get head. Then I will flip it 2 times. Then I get then at that time I could not get a head. Then three, then four. At first I flipped it 5 to 6 times and I get ahead. So here the time when you get ahead is actually refers to the first success. So it is called a geometric distribution. For example, here we roll a dice. If you played the ludo, then we roll the dice on which we have six total six elements. One, two, three, four, five, six. Because we and I want to get a six here. So here we have one, we have two, we have three, we have four, we have five, we have six, and at the end when we did it, at one we were getting six, at two we were getting five, at three we were getting four. So it tells you the number of the trials which leads you to six. First three occurring on each roll of dice. So it shows you that on which roll of dice we get a three. It's an example of a three. So what does it mean? Then I roll the dice how many times I will get a six. So here if we plot these things, then at when I one time I got I think eight, at two time I got four or five. So in that this is actually a scenario. Okay. Now the next thing is hypergeometric distribution. Okay. It is used when sampling without replacement from finite population. It means that, for example, I have two things, 20 red balls and 10 green balls. So what does it mean? That when I take these red balls, then I will never be used for my future sample. For example, I have as I told you, I have 30 balls and I took the 5 balls at the first sample. So at the second sample, I will not be able to take these 5 balls because I have already taken in the first sample. So this is the example, the drawing code from a deck without the replacement. When you take the sample of something and you don't want to use it in a future for the sample, then it becomes a hypergeometric distribution. Okay, now move towards the continuous distribution. In the continuous distribution, the first distribution is called, the most commonly used is referred to as a bell curve, or is a normal distribution, and it is represented by a bell curve. Whenever we have a distribution like this, it's like a bell curve, then it's called the normal distribution. And for example, we have a people based we have height of the people based on the IQs. So here it contains the 68% data. It contains if I am not wrong, it contains I think 95% of data, and it contains 98% of data, I think, if I'm not wrong. So it actually tells you that the distribution of data. And when we talk about the normal distribution, it is always represented by a bell curve here. Let's move forward. Okay, the second is called the uniform distribution. Uniform distribution means whenever we plot the values and all the values have a same equal probability. For example, I have I have plot different values based on the categories A, B, and C, A, B, C, D, and they all are getting the same values at a y-axis. For example, it become a plot like this. We have here it become plot like this here. You can see, yes, at y-axis we are getting the same values. So it is called the uniform distribution. Uniform distribution means the distribution which can be changed. For example, randomly selecting number between 1 and 100. Exponential distribution models the time between events in a Poisson process. the time between customer arrivals at a store. It models the time between the events in a Poisson process. As I told you about the Poisson distribution, when we calculate the number of events in a specific interval of time. So what does it do? Exponential distribution. It actually calculate the multiple events in a short interval of in a some short interval of time. It models the time between events and a position process. So as I told you, it calculated the time between different events happening. The next is the gamma distribution. Gamma is actually a generalization of exponential distribution. When we generalize the exponential distribution, then it becomes a gamma distribution. And the example is waiting time for a specific number of events in a Poisson process. For example, we have a Poisson process, and it's actually refers to the waiting time for a specific number of events which has happened in a Poisson process. So that was all from gamma distribution. And the second is called the second last one is called the beta distribution. It is used to model the probabilities or proportions. It actually represents the probability or proportions of some sort of events. For example, we have a defective atoms. I'm talking about the shop. We have defective atoms and also non-defective atoms. So beta distribution will show that it will shows you the different types of the probabilities based on the number of events. For example, I have 100 samples, okay, and out of them 30 are defective, so it will show you that 0.3% 0.3 probability of the things are defected. So this is called the beta distribution, which used to model the present, or which used to model the probabilities or proportion. So that was all from me. Thank you. Subscribe my channel. If you have any question, you can ask me in a comment section.